Hello everyone, this is the video for Group31, and our selected topic is methods to deal with delay of real-time multiplayer mobile game. Our group members are Shuai Wang, Lu Yangyang, Peng Cheng, and Feng Kai Wu. Firstly, what is real-time mobile game? Generally speaking, it requires the player use a continuous way to operate the game rather than by turn, and this type of game is always time-sensitive. For example, Players Unknown's Battleground. This is a typical instance of the real-time multiplayer game, but Hearthstone is not. As I mentioned, this type of game is always time-sensitive, therefore, network delay should have huge influence on the game's smoothness. There are several ways to deal with network delay on the mobile games, such as independent communication thread, choose different transmission protocol, choose different developing model, and more. This video will introduce some methods to deal with the network delay of multiplayer real-time mobile game. The first one is independent communication thread. What is independent communication thread? Basically, it is a multi-thread programming way to deal with the network delay. That means use different threads to deal with different type of events. To be more specifically, how does it work? As the flowchart shows, the left side is one thread way, and the right side is multiple threads way. In the one thread way, if the user does any operation to the game, the client would always need to send some information to server to achieve synchronization. But if the network situation is bad, the communication process may take a long time, and at this time, the client side could not do anything. That means the user could not see the result of his operation until the server replies the message and the client receives the reply message. But in a multiple threads way, this problem can be solved, as this diagram shows. We can separate different threads to deal with different type of events. The communication one is just used to deal with the communication between client and the server, and the calculation and draw thread are used to do the calculation and draw process. These two processes can be done locally without the server reply. That means if the network situation is bad, it can only influence the communication between client and server, but the client side could also do the calculation and draw process. The user could also see the operation results immediately. Next, I would introduce choose different transmission protocol to deal with the network delay. The most basic requirement of real-time multiplayer games is communication between players and server, which is sending and receiving data over the network. There are two main ways, TCP and UDP. TCP stands for Transmission Control Protocol. It is connection-based, which means a connection between two machines are created before exchanging data. The connection is reliable and ordered. All data is guaranteed to arrive at the other machine and in order you wrote it. TCP is a stream protocol, so it will automatically split your data into packets and send them over the network for you. UDP stands for User Datagram Protocol. Compared with TCP, UDP is a connectionless, unreliable, unordered protocol. It just sends a packet to destination IP address and port, and it gets passed from computer to computer until it arrives at the destination or is lost along the way. In practice, you always have some packets got lost, and there is no guarantee of the ordering of the packets. When writing the network game, we firstly need to choose what type of protocol should we use. Do we use TCP, UDP, or a mixture of both? In general, TCP will build a connection by three-way handshake before sending packets. If the player is in unstable network environment, the connection will be interrupted frequently. So TCP needs to rebuild a connection by three-way handshake. It needs some time before data sending. It would cause delay. On the contrast, UDP does not need to build the connection before sending packets. It performs faster than TCP. On the other hand, TCP is a stream protocol. It will first split a stream of data into packets. Each of them has an order number. Whenever a packet is dropped, it has to stop and wait for the packet to be resent. Yes, even if more recent data arrives, the new data gets put in a queue, and you cannot access it until that least packet has been retransmitted. It also causes latency. So we recommend never use TCP when networking time-critical data. Using UDP is a better way to deal with it. Furthermore, I would introduce some other way to reduce the network delay effect by using different development model. By using P2P or client-server model could also help to reduce latency in real-time game. In client-server model, the whole network system is controlled by several authoritative servers. In P2P network model, one computer could perform as a server and let others join. These computers could communicate with each other through application directly and store their files locally. There are many famous real-time games based on client-server model, such as World of Warcraft, League of Legends, and Dota 2. For the real-time games based on peer-to-peer model, Xbox Live and Mario could be the typical instance. This table shows some comparison information about client-server model and peer-to-peer model. In client-server model, distributed authoritative servers could generate that the player could experience a low latency or delay at different locations, while in peer-to-peer, if the players are from different countries, the latency problem will rise up significantly. And in client-server model, the servers could help to protect the connection and defend cheaters. However, in peer-to-peer, hackers could edit the data packet in order to cheat during the game. Moreover, the client-server model uses authoritative servers, which could also be easily to optimize and manage in order to provide a better connection service. However, in client-server model, server's capability has a bottleneck. If the client number hits the bottleneck, the latency problem will rise up. Furthermore, because the client-server model is using authoritative servers to provide main service, if a large number of players log in to the game at the same time or performing guard fighting in a huge scale, the traffic congestion problem will come up. These latency problems could be reduced a lot in some other way, like peer-to-peer model. When the real-time game is set up based on a local area network, there is no more internet delay anymore. By using of peer-to-peer, there will be a very frequently gaming experience. The peer-to-peer model also provides balancing latency method so that every player could experience a similar delay during gaming. On the other hand, if the authoritative servers are broken down at the same time, unfortunately, there is no service provided anymore. Well, in peer-to-peer, if the host is broken down, players could elect another computer as a server to continue their game. As I introduced, there are a lot of different ways to deal with network delay in mobile games. When the developing team are trying to develop a mobile game, they could choose different methods based on the situation they are facing. Okay, that's all about our presentation. Thank you for your listening.